Today we're talking about functions and relations. We'll also get into domains and ranges with that. So first thing, we just have some definitions. Set builder notation is what you guys are used to. You probably didn't even write the whole thing. You would probably just answer like x is greater than -2 last year when you did problems. The true formal notation has these squiggly brackets. That's a set. And it says the set of all x's such that x is greater than -2. Okay. I just want you to understand what that notation means. It looks kind of scary, but it's just saying any x where x is greater than -2 is the solution. You see that sometimes on ACT. They like to do the full notation, not just the inequality. The math Excel, some of them will have that full notation, and it'll be more like a fill in the blank. So they'll have the brackets, the x, such that you just have to fill in the blank in the middle. But that is the true notation. However, starting in this class and any math class you take beyond, we actually kind of get away from set builder notation. And we're going to start using what's called interval notation. I don't believe you guys ever did that in Algebra 2. I know they didn't used to, unless she changed it. I know her curriculum changed last year, so she might have thrown it in. In interval notation, it looks kind of like an ordered pair, but that's not what it is. You are giving a starting and a stopping point. You can have parentheses or square brackets. So parentheses are like normal. When I say bracket, I'm talking about something like this. A parenthesis means not equal to the number, and a bracket means equal to. So if I'm looking at this one, it was not equal to -2, so -2 had a parenthesis. When you do that, you're giving the starting and the stopping point. So if you think about if we had graphed x is greater than -2, okay, you guys would have done open circle and going this way, right? So it wasn't equal to -2, so that's a parenthesis, comma, it never ends, it goes forever, so we use this infinity symbol. It's like a sideways 8 to represent something going on forever. Infinity is not a specific number, so you cannot equal infinity. So infinity will always get a parenthesis, no matter what. If you were going in the negative direction, so maybe it was x is less than -2. If you want to go this direction, you would be coming from the negative, so you would call that negative infinity. So the first thing I want to practice is if I give you an interval, can we write, if I give you the inequality, can we write the interval that matches it? Especially at the beginning, it's sometimes helpful for people to draw a graph. That's not required, that's just if it makes more sense to you. If you're looking at it, this says 1 is less than or equal to x is less than or equal to 3. So that means you're starting at 1 and you're ending at 3. So interval notation, if we start at 1, what do I do, a parenthesis or a bracket at my 1? Bracket because of the equal to. Comma, then we put our ending point. Where does it end? And that's it. You don't include the variable with it, so we don't have to worry about putting x's if we're talking about domains and y's if we're talking about range. So that is kind of nice. All right, B. -4 is less than x is less than 0. What do you think that one would look like?
Parentheses, -4, comma, 0, parentheses.
And these don't have to be the same. You don't have to have 2 parentheses or 2 brackets. You could have one of each. You know, if I had an equal to on the 0, the -4 would have had a parenthesis and the 0 would have had a bracket. So we can have a combination. Okay, x is greater than 5. So if you think about what this means, we're starting at 5 and we want everything larger. So how would I write that? infinity gets a parenthesis no matter what. D, x is less than or equal to 1. So from starting at 1, less than or equal to, how would I write that? Let me get a practice. Did you guys use this at all last year?
I think so, yeah.
Okay. All right, so the next slide. She used to do all inequalities in algebra 2, but I thought she had switched to interval. So for each of these, I want you to write the inequality that would go with it. See if you can figure out what the inequality would be. So first one, what would we put? Good. B.
X is greater than 2.
C.
2 is less than or equal to. X is less than or equal to 3.
And D. All right. So we good with that? So now functions and relations. A relation is just any correspondence between two sets. Typically, if you're in a math class, you're thinking sets of ordered pairs, and that's what we're looking at most often. But in a relation, there's no rules on that relationship. Just any correspondence, any set of ordered pairs would be a relation. We call the x the domain, the y the range. A function is a specific type of relation where each input gets only one output. In other words, in a function, the x never repeats. Each x value is used one time and gives a single y value for the answer. So I want to look at each of these, decide if it's a function. Then we'll give the domain and range. Is A a function? No. Why?
Because it is 1 twice.
One repeats. Is B a function? Yes. Okay, the domain. We can't write an interval for this because it's only 4 points, so we're just going to write the set. What x's can we use?
1, 2, 3, 6.
Okay, the range.
4, 5, and 10.
Good. Even though the 4 gets repeated, it doesn't matter if a range gets repeated, and we still only list it once when we're giving our solutions. C, is that one a function? No. Why?
A3 repeats.
Okay, D. This is that full set notation, saying the set of all ordered pairs x, y, such that y is equal to x minus 2. So, to be a function, it's saying if I put in x, I get only one answer. So if I plug in a number and subtract 2, will I ever get more than one answer for that? If I do 3 minus 2, I get 1 every time. If I do negative 10 minus 2, I get negative 12 every time. So we're never going to subtract 2 and get 2 different answers. So this one is a function. My domain. Is there any number you couldn't put in for x? Is there anything we can't subtract 2 from? No, it could be anything. So to show that, it's the entire number line, so it's negative infinity to positive infinity. Let's get parentheses. The range. Okay, if y is what we get after we subtract 2. Is it possible to get negative answers when you subtract 2? Can we get 0? Can we get positive answers? So we can get anything. So it's also negative infinity positive infinity. Let's practice domain and range from looking at a graph. So on A, domain is the x. I can't do an interval because it's not all the values between certain numbers. It's just for specific points, so we just have to list them. So what would be my domain values?
-2, -1, +1, and +4.
It's just the x values of each of those four ordered pairs. The range is the y value of each of those four ordered pairs. So that would be
-2, +4.
it doesn't matter what order you put those in. Typically, we're going to do increasing order. But if you miss one, it doesn't mean you have to erase it all and start over. You can put them in any order. B. Will I list all the values or do an interval on this one? We would do an interval. Okay, so domain. We're thinking from left to right. Okay, so if I'm taking this line, okay, going from left to right, where does it first hit my graph? At -1. Does it actually touch -1? Yes, so -1 gets a bracket, comma, we need to know when it stops. So as this line travels, where is the last place it hits my circle?
+5.
And it does hit that, so that also gets a bracket. Range. So we're thinking about our y values. Okay, think of a horizontal line. Where we go small to large, so what's the first y value we hit? And then this keeps hitting values until we get to positive 2. C. Okay, this line keeps going. So as I'm going from left to right, if this line's going to keep going, what would be the first place we hit it? Infinity always get the parentheses. Comma. Keeps going forever in the positive direction, so the last place we hit it is range. Okay, if this is going down forever, what's the first place we hit it? And the last? D, what would be the domain on this one? Yep, that parabola just keeps getting wider and wider. The range, what's the lowest value we hit?
0.
And we touch it, so it's a bracket, comma, keeps going up forever, so it goes to infinity. So can we do domains and ranges from graphs? Right. How can you look at a graph and know if it's a function? If the domain doesn't repeat. So if I look at A, my domain didn't repeat, so that was a function. What about B? No, because if I look, I use 2 here and here. So the quick check is the vertical line test. If you can draw a vertical line that hits your graph more than once, it is not a function. If no matter where you draw your vertical line, it hits never or only once, then that would be a function. So look at the next slide, take a second and decide if each of these are functions or Alright, so this one is a function, passes vertical line test. This one is not, because you can draw a vertical line that hits twice. This one is not. What about this one? Yes. Alright, we're good with that. Final thing we want to talk about today, function notation. So that's when you're seeing the f of x. F of x represents the y variable. So when I say f of 2 equals 13, that's saying the x is 2, the y is 13. So ordinary can be written in function notation. So I want to practice finding f of negative 1 for each of these possible function representations. So on A, when I say find f of negative 1, what am I asking you to do? You replace the x with a negative 1. So negative 1 squared is positive 1. So we get 2 minus 9, negative 7. The f of negative 1. That's saying if x is negative 1, what is y?
0, 6, 8, 2.
Okay, but we need to look specifically. Those are the possible y values. But when the x is negative
6.
1, the y value is 6. Remember, it's a function. If we have that f of x, that's function notation. So we know it's a function, so we can only get one answer. Let's see. F of negative 1. So if my x is negative 1, what is the y? 5. Alright, D. This is sometimes what people struggle with the most on the graph. So f of negative 1. You're finding when x is negative 1, where are we at on the graph? So it would be that order pair on the graph. So that would be 0.5 or 1/2. If I said f of 0 on that graph, what would it be?
It's 2. Okay.
When x is 0, the y is 2. If I said f of 2, what would it be? Yeah, somewhere in between -4 and -5, kind of hard to tell, maybe -4.5. So in that function notation, I'm telling you the x, you're giving me the y. All right. Let's look at this one. So if f of x is 5 minus 2x, and I want to simplify each of the following. How would you find f of 4? So we get 5 minus 8 and negative 2. So f of a. We're not going to get a number here, but we're going to get an expression. We're just going to our equation and replacing the x with an a. So it's just 5 minus 2a. C, f of a plus h. This is where I tend to start seeing mistakes when I give something uglier to plug in for x. But all this is saying is you go to your equation and you replace the x with a plus h. 5 minus 2 times a plus h. So that would be 5 5 minus 2a minus 2h if we distribute the negative 2. And the last one, f of 5x. We have 5 minus 2 times 5x. 5 minus 10x. So you don't have to just get a number at the end. You could get an expression. Are there any questions for me? So there's a math Excel assignment open. You guys have time to work on that.